Hello again! In this video, we'll discuss the process of packing executables using the UPX packer and unpacker as an example. We'll do the analysis using IDA Pro and a few other tools. To save time, we prepared the UPX executable, which is available in the path. So we can just type UPX, see that we got the latest version. UPX is a legitimate packer, by the way. We can use it to perform the unpacking with the -D flag, and it has also a few options regarding compression and so on. We will first take a standard executable, pack it, see what are the effects of packing, and then understand the unpacking process and do it manually. Let's say we start with this executable, PEView, a legitimate tool. When we open the process, it asks us about opening a file. Let's open the executable in IDA Pro. Okay, let's see here. It has a lot of functions, and there are lots of imported functions also, as we can see. It looks like a normal executable. Let's see what are the effects of packing. We will use UPX to see the parameters. Okay, here we need -O for the output file, so -O PEView pack.exe. Okay, we generated an output file that is almost half the size of the original one. Notice here the size. We can check the packed version in exe info PE. Drag the file. It is recognized correctly and everything looks as expected. If we execute the packed file, we get the same interface. The application works perfectly fine after the packing process. Let's examine the packed version in IDA Pro. So drag the file, okay. Right from the start, there is a warning telling us that some imported modules will not be visible because the IAT, which is import address table, is located outside of the memory range of the input file. We will see why and how to fix the import table later on. Now, instead of tons of functions, we only have one start function, which is located in segment UPX1. In the export table, again, we have just one entry, as we can see here, but interestingly, in the import table, we don't have anything. This is a clear sign that we're dealing with a packed application, guys. So, when an application gets packed, it is actually wrapped in another layer, sometimes for obfuscation, sometimes for compression reasons. Our goal here is to identify and extract the inner layer, the initial application. Look at the code in IDA. It's not overly complicated, but still, there are a few blocks to analyze. The code flow looks challenging also. So, we can toggle between the graph view and assembly code using the space key. Let's scroll a little bit here to take a look. We need to be inside a function to use this feature. So, let's look for one. Let's play toggle back and forth. Click space and we'll be back in the start function. One neat trick that we can use in IDA to quickly spot what's happening is the flow chart, which we can open from the view menu, graphs and flow chart, or even simpler, just press F12 if you remember and like shortcuts. Here. Notice that it looks similar with the graph before, but there is something very interesting at the end. The code executes through all these blocks, and in the end there is something that looks like an exit point. Although it's the same code block, this graph view is actually a lot more efficient in spotting what's happening. Let's play a little bit with it. Scroll a bit, bring it into view. We reach this block in red from a jump instruction. So here, as you can see on the screen, what's happening here is that this is the end of the first layer, and at this point, the outer layer has already decrypted or unpacked the inner layer. So the jump will actually take us to the inner layer of the application. And a quick tip here, this graph application is not available in the newer versions of IDA Pro. In the freeware IDA version 7.0, the graph application binary is not available. So we would have to import it from a previous version of IDA. On your own machines, you have to get the executable and modify the configuration file inside the CFG folder here. So if we open ida.cfg, we have here, inside the configuration file, you will need to add something like, let's see, here, so graph underscore visualizer equals, and then the path to the executable. Here. Use this trick if the graph tool is not present in your version of IDA. Okay, having said this, let's continue. Back here. And from the graph view, we spotted this point, this block here, which we said is the end of the first layer. We will set a breakpoint here using the F2 key. Then we'll execute our application, which will stop before the jump. Select here the local debugger, which is actually the only option in the free version. Hit play, read the warning message, and we click yes, and we will land at the point just before the jump. Okay, so here. To do the jump, we either press F7 or F8. Something interesting here, IDA has detected that RIP, which is the instruction pointer, points to an address not defined as code. Let's click no here and see what happens. We'll actually reach a point in another segment, UPX 0. Before, we were in UPX 1. Here we have something that looks like a bunch of strange values, right? The reason IDA doesn't know to interpret this as code is because initially this was a data segment which was unpacked in memory. So we will convert it back to code manually. Okay, click edit, then code, and okay. Now this looks like an actual function. There are call instructions, jumps, and so on. While we're here, let's see how to recover the inner layer of the application, the one that was packed. Okay. The first tool we'll use is LordP to dump the binary from the memory. First select the executable, which is named with -pack at the end, so here, this one. Then we select dump full and save the dump on the desktop. Save, OK, the dumping was done. Remember that at this point, the application is paused after the execution of the first layer. So we're actually at the beginning of the second layer. If you try to run the dumped version, it doesn't actually work. Why not? This is what we will see forward. So, well, let's see. We will introduce another tool called Syla Import Reconstructor. Syla. The problem in this case is that although the code of the application has been dumped correctly, the imported functions are not there. We can check this with IDA Pro. In the dumped version, there will be no imported functions. Let's see here. So no imported functions. Although the code looks okay, nothing. So there are functions, but the import table has been messed up. Let's continue and we will see why. We'll reconstruct the import table. We'll open Syla. First, the 64-bit version. Here we have many versions, as you can see. So the 64 one. In the process list, we don't see our process. And the reason is that we have to use the x86 version for 32-bit processes. We select the process to attach, PEView -pack. Here we have some helper functions like IAT auto search. Here, if we click on it, okay. And then the get imports button below, we can see here, if we click on it, all the imported functions should be valid. The next step is to fix the dump. We will repair the previously dumped version. Okay, this one, open. Syla will create another version with _SCI E. Before moving on, let's verify that these functions are recognized correctly. So, Syla tells us the VA, virtual address, as we can see here. Let's take the first one, copy the first address, this one. Then we go back in IDA Pro to that address and check what's there. So jump to address, paste here. Doesn't look very interesting, right? But let's continue to dig in. This is because we're dealing with a block of raw data. We can convert back and forth between code and data using C and D keys. Okay? C and D keys. Make sure the offset is correct, then go back in IDA and to the address using the J key. Okay. Sorry guys, bear with me here, we're not interested in this big news. We return to our stuff here. So we were saying jump to address, paste there. This is the address. Okay, let's see here. We confirm. We will press D a few times to convert it to data until we get a double word. DW. here is actually an offset to a function. We can do the same with the next few, and we will reveal other functions. Okay. This is actually very interesting and useful. The function names match what we've seen in Scilab, and that's great, guys. Okay, so we got a dumped file. Let's check if it works. Double click, and surprise, surprise, it actually doesn't, or not yet. Let's check the information recognized automatically by Scilab, like OEP here. This should be the original entry point of the unpacked application. Take its address and check what's located here. So we copy it and we go back to IDA Pro. Here, jump to address. Okay, paste the address. And what we have here, let's see. What happened is that Scilab actually recognized the entry point of the main application. This is the start function that we've seen before in the outer layer. In Scilab, we need to enter the entry point of the second layer, the inner layer. Okay. Let's see here. So let's copy this one and enter it in Scilab, and then fix the dump again. Here, fix dump. But before doing this, I didn't press it. Actually, let's quickly examine the previous version in IDA. We have the correct functions reconstructed, and we also have the code. Everything looks fine, except the entry point. So that's why the program didn't start. Let's return to Scilab. There's the correct entry point, field in here. When dumping, select the original one and we click open. It should now be fixed. And let's verify, double click. We launch the dumped version and it should run fine without any problems. And if we open it in IDA Pro, the import table and other functions should be correct. Let's see. Here, we don't save to the database. Again, the application runs as expected. So guys, to recap, in this video, we saw how to manually unpack applications packed using UPX. Keep in mind that although there is an automatic unpacker using the -d flag, because the packer is open source, it is very easy for someone to take its code and modify it. That's why it's a good skill knowing how to unpack UPX manually. I hope you liked this video. Thank you very much for watching, and please leave us your comments and feedback. Cheers!